Imagine you are on a holiday at your country house. It's late on a Saturday night and you decide to take a walk out in the open fields neighboring your countryside house. There is a nip in the air and the moon casts a silver blanket of light on everything around. You look up and are greeted by the sight of thousand pinpricks of light scattered across the night sky. For a moment, you are lost in their beauty, and you think to yourself how filled with the life everything feels. Truly an unparalleled sensation. Yet little do you know that the most of the stars that you look at are actually quite dead.
Not just that, but one day our sun will end too, and humanity will receive the brunt of it. Quite a dilemma, is it not? Good day to y'all. My name is Siddharth Rangnekar, with my friend here Sarvesh Bhogakar, and we are here to present to you star formation and the life of a star. A star is quite the fascinating entity. It undergoes a life cycle akin to any other living organism. In that sense, stars are quite alive. It all begins with the collapse of a gas cloud present in a nebula. These clouds are made up of approximately 90% hydrogen and a plethora of other gases. If these clouds are massive enough, it undergoes gravitational collapse. A scientist named Sir James Jeans gave an upper limit to the mass of the gas cloud, after which it will undergo collapse. As this cloud collapses, the material at the center begins to heat up and form clumps. It is this hot core that one day will become a star. This whole process is long though, takes about 10 million years.
Eventually, this clump breaks off from the cloud core and has its own unique gravity. This is what we call a protostar. As it forms, loose gas falls into it. The infalling gas releases kinetic energy in the form of heat and thus the stars heat up, becoming an irradiant source. Initially, it only has about 1% of its final mass, but over the time, the infalling gases add to it. Well, we saw how a generic star is made, but we all know from the pictures we see on the internet that no two star is exactly the same. They come in various sizes and have different colors ranging on the visible spectrum. And it is this uniqueness of stars that makes us want to study them even more.
This piqued the interest of two notable astronomers, Ina Hertzsprung and Henry Norris Russell, which further proceeded to plot a diagram of the stellar temperatures and luminosities. Consequently, they found out that stars are not uniformly scattered across the HR diagram, but are confined to a fairly well-defined band stretching from the top left to the bottom right. These band of stars were called main sequence stars. They are all assigned to a particular class according to their atomic spectra and their temperature. For example, O is the hottest and blue in color, while M is the coolest and red in color.
Now, main sequence stars are actually quite young in the life cycle of a star. We also have red giants, blue giants, supergiants, white dwarfs, neutron stars, and pulsars.
And now we finally come to the last stages in the star's life, its death. Stars don't all die the same way, but we shall see that as we move along. Firstly, eventually the star's core will run out of hydrogen fuel, and it will contract under the weight of its own gravity. Then as this core contracts, it will heat up, which in turn will heat up the upper layers, causing them to expand, and turning the star into a red giant. You may think that's not so bad, but at this point, if we were still living on Earth, humanity would have already perished, because the sun's red giant radius is just beyond the Earth's orbit. Anyway, the star will then start burning the helium fuel into carbon. But eventually, even this fuel will run out. What then?
Here is where two paths open up, one for stars like our Sun and the other for stars more massive than it. For stars like our Sun, the core will expand and then start cooling. Due to the loss of gravity, the upper layers will start shedding off material. The core will eventually cool down to become a white dwarf and finally a black dwarf. over the course of a few billions of years. For the second part, once the helium fuel is used up, the process doesn't stop there. It carries on to more heavier elements like oxygen, neon, silicon, and so on till entire core has been converted to iron. The star then collapses under its own gravity and this core starts to heat up, becoming tightly packed. The contraction causes the core to heat up to billions of degrees and explode, commonly called a supernova. The remains of this core then forms either a neutron star or a black hole, depending on the mass of the original star. An Indian astrophysicist by the name of Subramaniam Chandrasekhar gave an upper limit to the maximum mass of a stable white dwarf star, beyond which it would undergo collapse and form either a neutron star or a black hole. It would be 1.4 times the mass of our Sun.
Such is the life cycle of a star. The same energy that makes a star so brilliant and brings it into the universe is the very same energy that destroys it. It is quite apt when one says that stars are the plants of the universe. They recycle the elements and strike a balance between them. An interesting thought would be how mankind will deal with this inevitable death of our sun. Will we have developed enough technologies to leave the solar system altogether and maybe have settled in another system far off? Only time will tell. Well, and with that, friends, our story comes to a close. We thank you for embarking on this journey together with us, and we hope that you took away something from this video today. Good day to you.